Hello everyone, and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. My name is Corey Nook, and I'll be helping with today's demonstration having to deal with linear superposition, and more or less the topic we'll be covering are beats. So you might have heard this every once in a while in just listening to music or especially on campus here. If two instruments are maybe not on the same frequency, you might get them to be having a unpleasant sound, or you might hear a slight, almost Doppler effect, where you might hear different amplitudes or different intensity, where it might get loud, then soft, then loud, and soft, even though they're not playing the same note. Or especially if they're trying to play the same note, and it's not exactly the same, you might get a beat frequency, but it's going to possibly not be pleasant to your ears. But we can also have to where with the superposition that if you're trying to play the same note, they'll actually amplify with each other instead of just having it by itself. So right now I have these two tuning forks just attached to wooden boxes to help with the amplification of sound. And I just have a little striker here to help make sure that the maintenance of these tuning forks aren't destroyed. So I'm going to hit one. You can notice the sound that's producing. Now I'm going to hit another. Should have hopefully heard the amplitude or that sound, that frequency doubling, because it had this one wave pattern from here and the one wave pattern from here are both the exact same. So if it's the exact same wave pattern, as you see on the board, the sinusoidal wave, if they'll add together, you'll just increase the amplitudes, which would be quote unquote like increasing the intensities, but you're not changing the frequency. So let's see if I can do that again. So hopefully you heard an increase in that amplitude. But now what I did is I took the exact same frequency and I put a little metal bar on here. That's going to change what frequency this is. So with that change in frequency, we're going to have two different waves that are now going to try to add together. And where you have a trough and a peak will cancel each other out. But where you have the two peaks happening at the same time, they'll add together. So now if I was to look at, now between the two of you, you hear that dun, 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 almost like when you're hitting a bunch of bumps on the road. So let's try that one more time. Let's see if maybe this helps. You hear that almost oscillatory pattern, and that's the waves interfering with each other, causing those beats to happen where we have a overall pattern that does not line up exactly with each two, creating its own unique peaks and valleys. So let's just do this one last time for demonstration purposes. Well, hopefully that helps gives a better visualization of beats and the concept of superposition between waves. Thank you for watching this short video presentation, and have a wonderful day.